Welcome. In this video, I'm going to help get you started on evaluating this integral, and then I'm going to ask you to pause your video and try it yourself. So we want to integrate e to the x sine x. Well, I'm going to let u equal sine x and dv equal e to the x dx. So now du is equal to cosine x dx, and v is equal to e to the x. Please pause your video and rewrite this integral using integration by parts. Okay, so you should have rewritten this, that is sine x times e to the x here, minus the integral of cosine of x times e to the x dx. And now looking at this integral, we need to apply parts again. So let u2 equal cosine x, dv2 equal e to the x dx, then du2 equals negative sine x dx, and v2 is equal to e to the x. Now pause your video again and rewrite this entire line by applying parts to this circled integral at the end. Okay, so you should have written this down. That is e to the x times sine x. That was unchanged. Since we applied parts to this integral here, and there was a negative in front, I wrote a negative in front of this application of integration by parts. And then all I did here was distribute the negative sign. And what do you notice? Well, we end up with another integral that would require parts. But luckily, we end up with negative e to the x sine x dx, and we have a positive e to the x sine x dx. So let's add the integral of e to the x sine x dx to both sides. And what you end up with is 2 times the integral of e to the x sine x dx equals e to the x sine x minus e to the x cosine of x. And I know I'm ignoring the constant, but I'll put that in at the very end. We can multiply each side by 1/2, and that leaves us with the integral of e to the x sine x dx is equal to e to the x over 2 times sine x minus cosine x plus the constant c. So this integral evaluates to this expression. I hope this video was helpful.